All right. Welcome, everyone. So today I want to discuss frameworks. What they are, why we need them, and what I've learned from building more than one, actually, in my experience. So let me begin with a fundamental problem, which is when you're building web applications, when you're working in the browser, immediately you start hitting problems, right? The web browser gives you some useful functions, but when you first start building applications, immediately you start asking, how do I do this, right? How do I do routing? How do I do data binding? How do I do this? How do I do that? And the answers to these questions are not immediately obvious to you. Now, after a while, once you begin programming in the web, you begin to notice some patterns. And you begin to realize that the same kinds of problems start to appear. In fact, these problems can be categorized into problem sets, right? So there's a whole set of problems relating to rendering, right? Is how do you actually get pixels up on the screen? There are a whole set of problems relating to state and state management. There are problems relating to synchronizing state with the view. There are questions about how do you synchronize that with the back end. There are performance questions. There are security implications. All of these things have to be considered and some of them solved in order to create a working web application. Now, there are a few schools of thought regarding how you can approach this. In the very beginning, what you can start doing is when you hit one of these problems is just start writing code, right? Just start hacking around it. Just figuring out a solution based on the primitives that the browser gives you. And this is fine at the beginning, especially if you're building something fairly simple. But you know, after a while, what you'll realize is a lot of these problems that you're solving keep coming up. It's the same problems that keep turning up within a web application. Within a project, but also in different projects. Even if you work on a different project, you realize, oh, this project has a lot of the same problems that this project has. And what you begin to quickly realize is, I need to make my code a bit more reusable so that it can be used not only by myself, but also by other engineers who I'm working with, right? So, I'm a professor here, so I get to do that. Right, so it's important, so you will quickly realize, okay, rather than keeping my code coupled with the project that's there, it may make sense to pull it out into a separate library and then maybe npm install it into all the various projects that I want to use. And that will make my code reusable. So what you end up with is libraries. Libraries are fantastic, right? Libraries are tools in your tool belt that allow you to get things done. Now, it's also important, I think, to leverage other people's work, whether it's work created by others within your company, or it's by the people developing open source projects or whatever. Now, one concern that people I've heard have voiced about using other people's libraries is they're worried about tightly coupling their projects to that library, right? One simple solution to this is to simply wrap that library with your own API. Right? If you create your own API and you have the library simply be an implementation detail, which can be swapped out by another library or by your own implementation, right? So this way you can decouple the library that you're using, the third-party library, from your core project, is by creating this layer of indirection in between. Libraries are fantastic, but remember that libraries have to be used in composition. They have to be used together. You're building a project, and you're not going to have one problem. You're going to have many problems. You're going to have to solve lots of different things when you're constructing your project. So intuitively, you would think, okay, you would need different libraries. Now, the problem with different libraries is many of them are written by different people. They have different patterns, different APIs. Some take callbacks, some return promises. Some have the method signature is very different. There can be very low consistency across libraries. So if all you want to do is build applications by just cobbling together libraries, that's cool. But you're still going to have to end up writing a lot of glue code. Code that is needed to do all the translations and transformations to get the libraries to work well together within a single system. Right? So that's the first problem that you'll immediately encounter if you only use libraries. And of course, I'm talking about building non-trivial systems. If you're just building a website, obviously none of this matters. The second thing, a library will help you figure out how to do something, right? So a library is an encapsulation of some logic that someone else wrote, and it helps you do something. But it doesn't help you figure out what to do and when. That is still your responsibility. And I would submit to you that unless you've written multiple web applications, it's very difficult to understand what is the right way to structure your code, what is the right way, and when should you call what. In other words, figuring out the right execution path within your code, the right way to manage the system, is actually very difficult. If you haven't built a web application in the past, doing it the first time is very hard. There's a second problem, which is you work on a team, ideally with lots of awesome, talented engineers. And here's the thing. If you just give libraries, every talented engineer on your team will figure out a different way, a different combination, a different execution path to solving the same problem. In other words, even if you're using common libraries, the code written by one engineer, the structure of the code, will end up looking very different from another. We all want to build applications that are scalable. We all want to build applications that are maintainable. The problem is the code has to be readable in order for that to happen. What do we need for readability? Well, one thing, the less code you have, the better, right? Because it's easier to understand less code. I think that's clear. But the other thing is consistency. I think this is absolutely key. I've personally had the experience where I worked with a very talented engineer. Actually, this has happened many times, where they come in and they will implement a module. And in the user interface, it looks beautiful, right? It fits in with the rest of the application, and it's fantastic. But then you open up the code, and it's written in a way that is completely different from the way that the rest of the application has been written. This, I submit to you, is a problem. Because what this means is in order to understand this code, when you're debugging it, when you're trying to add features to it later, you're going to have to go through and learn and understand how this code works. You can't apply the same knowledge, the same understanding that you learned from reading existing code to that code because there is no pattern, there is no consistency. Imagine every time you open a file, you have to relearn what it's doing. Ideally, in a project, you create these patterns, right? Whenever you do routing, this is typically how you do it. Whenever you do data binding, this is how you do it. And if you stick to that pattern across your project, reading code from one module to another becomes much easier. It's easier to understand code, which is absolutely fundamental. So we want consistency. And this is where frameworks come in. Frameworks are not functionality alone. A lot of people misunderstand frameworks, and this is the thing that the whole talk is basically framed so that I can deliver you this fundamental message. The responsibility of a framework is not just to give you functions, like, call this function to do data binding, call this function to do, routing or whatever, right? It's part of it. It's a critical part of it. Your framework has to have functionality, otherwise what is it if not that? Absolutely. But there's another fundamental thing that is in a framework. Encoded inside the framework is all the experience and knowledge from engineers in the past that have already built applications, that have already made mistakes, that now understand how how your code should be structured, how the management of the system should be done, so that you can leverage it and take advantage of it. I think this is key. The difference between a library and a framework is exactly this. A library is a tool. It's a useful tool, but it's your responsibility to use it and use it correctly. All the responsibility for managing your application, the execution flow when using a pure library is on you. With a framework, it's flipped around. The overall structure and management of the system is done by the framework. You simply fill in the gaps that then the framework calls into in order to run your application. So a lot of the core functionality, a lot of the core management that's done is done by the framework. And again, why use a framework? It's a huge responsibility to develop a framework. It's not just having data binding. It's not just having routing. It's not just making sure that there aren't security flaws and that it performs well. These are functions that you need. But really what has to be baked into the framework is all the experience from existing engineers that tell you, here's the best way to construct your application, in their opinion. Now, as you can imagine, there's no one way to build an application. There's no one way to manage a system. There are lots of ways and there are lots of opinions. This is why we have such a rich ecosystem of frameworks out there. A lot of people get daunted when they first start, they enter the market, they're like, okay, I'm going to become a web developer. And then they get scared because they see so many frameworks and so many libraries and they complain, and then the backlash to that is, write vanilla. In other words, don't use all this awesome code that other people wrote. Instead, start with the primitives and figure it out yourself. You can do that, but you won't get the scale you want, right? There's a reason why we have so many frameworks, because there's so many ways to do it. Different people have had different experiences in building web applications. Therefore, there are different encodings of these experiences out there, which is why we have such a rich ecosystem of frameworks. Now, should you decide to write your own framework, here are some of the things that I've learned along the way. It's important that your framework not only have the functionality, but it also has the documentation and the tooling and everything else to kind of force users to follow a particular structure. You are responsible for maintaining that structure. You are responsible as a framework developer of understanding all the programming patterns that are necessary to produce a successful application in the end. It's a huge responsibility. So, a few things. The first point of contact between your framework and the developers is your API, Application Programming Interface, right? Anytime you think of interface that a user is going to use, in this case a developer, UX has to be a priority. I said that, you heard me correctly. UX when building APIs. Always consider the experience of the user who is using your API, who is calling into your APIs. This is fundamental, and I'll come back to that in a moment. When building APIs, actually any APIs, it's critical that you keep them small. An API is a promise. It's a promise that your module makes to the rest of the system that says, you call me in this way and I'll have this kind of behavior. Promises are hard to keep. It's a fundamental principle. The more promises you make, the harder it is to keep them, right? Make as few promises as you can. Keep your APIs small. Furthermore, by having a smaller API, people are able to better understand your APIs, because I'm sure you've had this experience of opening up a library or a framework or whatever that has like 1 million functions in it, and like go try to figure those out, right? Having a small list of very useful functions is much better than having like 50 kind of random functions with redundancies. It's important to eliminate redundancies. Simple example. I've seen in one API, I saw like remove item and remove items. That's 2 functions, right? The only difference is remove items takes an array of whatever you want to remove. Remove item takes one thing. Why not just call remove, first of all? Why remove items? Seems a bit redundant. And second, why not simply normalize the input? Remember, we can overload our functions, right? We have function overloading in JavaScript. Why not simply say remove, take whatever, and then normalize it to an array? If it's already an array, keep it. If it's not, turn it into an array. And then do the for each and implement your removal. Simple, right? You've now cut down 2 functions into 1 manageable function. Keep your APIs small and make them easier to use. Make your functions intuitive. It's important that you have consistent naming conventions, right? You want to have functions look the same across your API, right? Don't call it remove in one place and remove items in another, or delete somewhere else, right? Try to sort of keep a standard API so that it's easier to use. The second thing, try to make your API look like something that people already know. This is critical, okay? People don't want to learn a new thing. They're very lazy. I don't know if you've noticed, but judging from people that came here at this hour, people are lazy. They don't want to learn something new, right? So if you can make your API look like an API that they've used in the past, intuitively they can now take the knowledge that they already have and apply it to your system. That decreases the cognitive load, right? That makes it easier to understand your system. One thing that you could actually do is, if you're building an API, try to find a system, an existing system that's kind of popular that does a similar thing. If you find something that does the same thing, you're doing something wrong, right? You might as well just use that. But find something similar. And then if you like the API, copy it. The API. The implementation, of course, will be yours. But this way, people that have used that system can apply that same knowledge to yours and immediately understand how it's going to work. I learned this from one of my JavaScript heroes, John Resig. He created jQuery. He's just an amazing guy, really smart, from Boston. So you want to keep your APIs orthogonal. What do we mean by this? So what I mean is anytime you have a function in one direction, you want to have the opposite. If you have an undo, you want a redo. You want to push, you have to have a pop. Create, delete, right? Next, previous. Now what I just told you, or first, last, whatever, right? You want to have the opposites covered. Why is this important? I've seen very often in framework development or in library development where you often will develop your APIs based on need. Right? So you're building an application, you realize, oh, I really wish this library had this function. Ooh, I'm the author of that library, I'll add the function. Score, right? So you go and you add the function, fantastic. But every time you add a function, first of all, be very careful about adding functions because you want to keep your API small. But when you do, it's very easy to forget about this concept. You might say, oh, I wish I could get to the end of the, the list. I wish I could get, last index of or last of or whatever, right? But oops, you forgot the first, right? So you forgot the orthogonal version. CRUD. Why do we keep repeating this idea of CRUD, right? Create, read, update, delete. So that when you're building your web APIs, immediately when this pops into your mind, you remember, okay, I have to be able to create it, read it, update, delete it. It's a way of making sure that you remember all the functions and you keep your APIs complete. You don't want to omit a function just because you forgot to add it, right? So as long as you think orthogonally, you won't forget to add the necessary functions to your framework and you will have a complete API. Encapsulation is absolutely key. Don't leak your internals out into the system. In JavaScript, it's very easy to leak a global, especially if you're not running in strict mode. By the way, just as a side note, I've noticed a lot of people writing useStrict inside of modules. You realize that modules already run in strict mode. Writing useStrict is redundant. You don't need that. So delete that code. So that's one. Two, prototype, we have prototypal inheritance, right? So it's very easy to do something like object.prototype and then start throwing things in there. Again, you're leaking your internals out into the system. Big no-no. And the last thing, and one of the, the things that have frustrated me the most, I would say, is CSS. CSS is inherently global, right? If you just create classes or whatever, those are available everywhere. There are lots of ways. React has very good solutions. Vue.js does very good solutions about trying to make class names that are sort of unique based on the component that you're making. Whatever solution that you use, make sure that you encapsulate your CSS. Don't let you, if you have a component and I pull it in, it shouldn't then modify other elements within my application, right? Keep your stuff encapsulated and enclosed in your system. Don't let it leak out. So documentation. It's important to have documentation. But it's not just enough to write, here's my function, here's what it does, and here are the arguments. I think code samples are absolutely critical. Again, going back to UX, right? Think of how you write code, right? I don't know how you write code, but the way I write code typically is when I'm using a library, I go and find an example, I copy it, and I paste it, and then I just tweak it, right? I'm guessing this is what most of you do as well. And this is a good pattern, right? Why force someone to sit there and write boilerplate? If there's already something there, if there's already a common pattern, they just need to change the inputs to the function, why not do it, right? Provide the sample code. So documentation is absolutely key. Error handling. This is one of the things that I think fundamentally determines how good an API is how good it can handle errors. A few things. First of all, you don't want to bring down too many strings with errors when you download because that will make your file size very large. What I like to do is I like to have all my errors be functions that you call, and then there's a template which then returns the error as a string. So, for example, let's say there's an input error, right? Well, the input has an argument, like which argument name is the error. That would be passed in as the template, which would get swapped into the string and return the actual error string. So in this way, I'm able to reuse that same error template over and over in lots of different places, thereby not duplicating the string everywhere and not having a massive file size, right? So file size matters. The second thing, whenever you give an error to someone, again, UX, think about it. What is the next thing they're going to think, right? They receive the error, they're going to think, oh, I did something wrong, fine. The next thing they're going to think about is, so what do I do now? This is the key question that you have to answer. What is the next step? What is the next thing the user should do in order to fix the error that they just got? So one thing that I like to do is I like to just mint a URL, which is just a link, which, again, the domain is constant, so that's just a short string, and then the path and maybe a hash that allows them to jump directly to the documentation of that function, right? So now if there's an error, oops, I made the wrong input, but what should the right input be? Does this input accept numbers or booleans, or what is the expected input type? I click on the URL, it goes directly to the documentation, directly to the function, and now I can read it and know, okay, this is what I did wrong, fix it, and I'm done, right? So having the URLs that reference your documentation directly as part of your error, super useful. React does this really well, other libraries do too. So let's follow this convention. There's the sort of there's a problem commonly known as N+1. No matter how good you are, no matter how amazing of a framework you build, there's always going to be some functionality that you miss, some use case that you miss, something that somebody wants that you don't have. One thing you can do is every time someone makes a request is you can just write more code, right? And keep sort of adding to your framework and making it bigger and chunkier and larger. Another thing you could do, though, is create a system that can support plugins. If you do this, what you can do is maintain a small core. This is the core of your framework, and then allow other engineers to develop plugins into your system. This way, when other engineers want to use your system, they get the core, which is small, has a small footprint, no problem, and then they can go and get the plugins that they want, but not everything else. So in other words, rather than having one massive framework that tries to do everything, you have the small core that then has plugins that users can just choose which plugins they want, and off they go. This decreases the footprint of the system, and it makes it easier for you to maintain a small core rather than a large system, right? So try to make a system that is extendable, if possible. As I said, whenever you make promises, you might end up breaking them. Why are promises broken? For a few reasons. One is, you're refactoring your code, and you end up sort of introducing a bug. And that changes the behavior, thereby breaking a promise. At this point, really, the only tool that we have is automated testing. Any framework that you write has to have an automated testing suite. It has to. Otherwise, how do you know if you've ever broken a promise? How do you know if after a refactor or an optimization or a tweak or a feature, if that change has had a negative effect on the system? You need tests, but be aware of one fundamental thing. Tests tell you about existence of bugs. They don't tell you about non-existence of bugs. In other words, just because your test passed doesn't mean that you don't have bugs. Understand this and just be aware of that fact as far as, when you hit git push. Okay, opinions, critical. As I said, a framework is basically an encapsulation of the knowledge and experience of developers, right? There are lots of ways of building applications, and sometimes it's difficult to say which is better. Sometimes it's literally just a matter of opinion, right? One way of organizing your code might be just as good as another. But at some point, you have to choose. If you don't choose, what you can easily get is having different engineers on the team choose different paths. A framework must be opinionated. It must force all engineers, everyone working on a single system, to conform to a single pattern, to conform to a single structure. When writing a framework, it's important that you have opinions. How do you enforce your opinions? Well, APIs are one way, but you need more than that. I found that having code examples is good, because what often will happen is people will copy and paste the code. And if enough people are copying and pasting the same examples, code starts to look kind of the same, right? Because they've literally copied and pasted these small function calls. Number one. The second way is to use tooling. So let me get to that. So having tooling and scaffolding is really useful, right? Instead of having the users of your system sit there and write everything from scratch, if they can simply run a command and get all the boilerplate right off the bat, and then just fill in what they need to and tweak what they need to, this is super useful. And in my opinion, a framework is not just the code. It's the tooling, it's the scaffolding, it's the code examples, it's the documentation, it's the community around the system that's always updating, Stack Overflow and putting more code examples. All of this together is the combined understanding of how to build a web application. And it's something that is necessary, and it's something that you can leverage when building applications. So, frameworks are awesome. The key takeaway from this is that frameworks are the efforts of other engineers to help you build applications. Now, again, different engineers have had different experiences. They have different opinions, which is why we have such a wide and rich array of frameworks. Go out there and find an existing framework that fits your needs, and if you don't, build one yourself. Just understand that it comes with a grave responsibility. Thank you so much. Questions? Yes? Okay, I'm not going to tell you because that's opinion, and I don't like to argue opinion. I honestly don't have a favorite framework. I'll be honest with you. I'm a React guy, if you will, at this point. I use React a lot, if that's sort of your question. I'm a big fan of the React ecosystem. Doesn't mean I don't like Vue. Don't start. Here's the thing, and I actually love Angular as well. One of the things, by the way, that I noticed immediately is, Angular the team at Google wrote Angular 1, which became wildly successful, right? Everyone was using Angular 1, it was amazing, it was terrific, and then suddenly that team of really smart people went off and created Angular 2. Now you might say, why would they do that? Why would they create this ridiculously breaking change when they already had such a successful product? And I think, going back to my point of making frameworks is hard. And every time you build a framework, you learn so much about application development. And also over the course of that fact, you build other applications that you realize, a lot of the assumptions, a lot of the opinions, and a lot of the ways that I constructed this were actually not optimal. I know of a better way to do it. And then they go and they build. I've personally rewritten the same framework 6 times. And again, why? It's not because I don't have anything else to do. It's because every time I built a framework, and then after a while, after using it, after building enough applications, I realized, there's a better way to do all the things that I had encoded into that framework. And so I go off and build the next version, and the next version, and the next version. And this is one of the reasons why Angular now is like Angular 2, Angular 3, Angular 4, Angular, right? Because they keep finding better ways of doing things, and they keep pushing them in. React as well, right? You keep getting new versions of React. They're now trying hooks and all these other things because they keep finding new ways of constructing these systems. So it's, okay, I'm not going to tell you which one I think is the best. I think all of them warrant respect and all of them are great. I personally am using React. That's all I'll tell you. Yeah? All right, cool. Because it's just JavaScript and I love that. Okay. Other questions? No? Oh, I'm sorry. Yes, sir.
Hey, so when you told that, I can guess you made quite a few frameworks, right? So, like this?
I can hear you, yeah.
So when you mentioned making frameworks like small, the core, and then adding modularity, yeah, that's clearly like a plus. But I immediately thought about Django. So Django just literally made a unicorn, right? It's their logo.
Okay.
So Django actually made just a unicorn. They added absolutely everything. So I guess there is modularity, but it's not even used. So how do you think, was Django in that matter a success of making like a big unicorn and still maintaining it functional and easy to use?
Yep.
In your personal opinion?
That's a very good question. Okay, so a few points. So first of all, the frameworks that I was talking about were mainly based in the browser. And whenever you're talking about any code that's going to end up in the browser, size matters, right? Just literally the bits that are coming down the pipe matter. The larger file size, the longer it's going to take to download it, right? The very simple, primitive answer is that. So that's one reason why you want to keep a core and then just use the plugins that you need, but not get the whole pack. That's one thing. Second thing is, I'm not suggesting that it's not possible. I'm just saying it's hard. I mean, just think about it. I mean, maintaining a big code base, is just harder than maintaining a smaller code base. You're going to end up with more bugs. You're going to have to do more documentation. You have a lot more things that can go wrong. And you have a lot more things that you have to keep synchronized, right? So my recommendation is always to keep a core that's functional, that works, that you know is tested and well documented, and there's a community around it. And then you open the rest up for plugins. The second thing is if you have plugins, you can now leverage other engineers. In other words, people can go off and create their own plugins without even bothering you, without making pull requests that you have to then review the code for and all this stuff. They're kept outside of the system, right? And they're kept separate. So this, for all these reasons, I think it's very useful to have sort of this modular approach. Is that fair?
Yeah.
Cool, awesome. Good question, thank you. Other questions or concerns? Yes? Okay, my time is up. Thank you so much, guys.